Hey folks, I'd like to discuss the topic of replacing capacitors on a Sega Genesis Series 1 motherboard, specifically electrolytic radial can capacitors. And in this video, I just like to cover, I think, two primary areas. One, why replace capacitors, especially if there aren't any perceivable issues in the system. And two, my technique in removing them and prepping the mounting holes vias for the new component to go in. It can really be a struggle at times to clear that solder from the hole, and I've got a method without any higher end specialty tools. So let's start first of all with capacitors. I've got this system here, picked it up, and really it worked. There weren't any issues with it. That being said, I come from a background where oftentimes critical components, instrumentation is calibrated, adjusted, repaired, regardless if it's in spec or not, because it has an interval. So it's done on the premise of preventative, right? So yeah, a lot of times when humans get their hands on things, they introduce errors and problems and they break shit. Well, that's okay. I'm going to go through this. You know what? If it doesn't fire up, well, that's my responsibility. I'm going to have to go through every single cap, make sure the polarity is right on the cap, make sure I have all good solder joints, and I didn't introduce any problems around the circuit board, like, you know, splatter of solder, shorted some pins or something. And the way to minimize that too is to go over the whole board with a fine-tooth comb, magnifying glass, jeweler's loops, and make sure it's clean and ready to go into service. Let's go over here to the capacitors. So why replace capacitors? Well, gosh, what do capacitors do, right? They have several functions. They block DC, pass AC, they store a potential, and they filter noise. Well, oftentimes capacitors slowly degrade on the effectiveness of doing those jobs I just described over time, because there is an electrolytic build inside the radial can, wrapping of material that dries out, that can leak from the top or bottom. But they can also suddenly fail, and one of the primary ways they can suddenly fail is if you go beyond that rated voltage. So like this 16 volt here, this is 100 microfarad 16 volt. You pump 30 volts to this guy, and what'll happen is it'll just blow. So it'll cause an open, so it'll suddenly fail. But oftentimes that doesn't happen. What happens is over time they degrade on their effectiveness. So when did this, I think this board says 1991 on it, right? So that's over 30 years old, okay? What's the lifespan of an electrolytic capacitor? Well, it depends on its environment that it's been in and the rated specs, and also the manufacturer. Some of them have better reputation with quality, but it's approaching end of life for a lot of these capacitors. One thing you can do, you can buy special meters to measure in circuit. That's another thing. You can't measure the capacitance with a multimeter, with a capacitor in circuit, because there's so many other components that are common to those two leads, the positive and negative lead, that it won't get an accurate measurement. So you would have to lift a lead or remove it completely to measure the capacitance. Well, there is a way you could do it in circuit, and you could use one of these meters. It's an ESR meter. ESR is equivalent series resistance. And what it does is it actually sends a sine wave frequency to measure an equivalent series resistance across the capacitor, and you can reference that with some charts. For instance, I don't know if you can see on my phone here, this chart where there's this cutoff. So for, say, a 10 microfarad 50 volt cap, the ESR should be no more than 2. I'm assuming ohms when you're talking about resistance, but no more than 2 is measured on the meter. And if you measured 2.2, well, you're beyond that cutoff. It doesn't mean the capacitor's broke, it's not functioning, but it's certainly not functioning at its prime. So, ergo, replace it. And what I've done, I've got this list from Console 5. There's a capacitor map of the board here, which is nice. I'm measuring the ESR of the caps that come out and the ESR of the caps that go in. I actually ordered 2 kits, and I'm picking the lowest ESR between the 2 kits. Now, they're going to be higher because really nearly all of these caps that Console 5 offers are higher voltage rating, which is okay. It just means that it's probably going to last longer than a lower voltage rating. So that's one thing you could do. Or you could just elect to say, you know what, I want to refresh the entire board regardless of the ESR. They're 30-year-old caps. The expected lifespan of them are maybe 35 years, and just replace them all. So that's that on the capacitors and that talk. Now let's move on to actual work on the board and some tips just to share with you guys what I do. Gosh, these are honestly kind of a pain in the butt, but I have my method. All these black ones here are the new ones. The blue ones are the old ones. Anti-static wrist strap. Now, I don't always wear this. I find it's very annoying to wear, but I have it mounted to a ground post that goes into my power strip back here. So some tools you might want to invest in to do this job. Anti-static strap, 99% ISO for cleaning the board, jeweler's loop, a good soldering station. And what I mean by good is probably in the at least $50 range, though you could go cheaper. I run mine at about 330 to 340 C. What else? Some good flux paste, non-corrosive, is very good. Solder tip cleaner, which is just kind of a metal Brillo pad of sorts. You can also use a wet sponge, which normally goes here in the tray, but I stopped using wet sponges a long time ago. Soldering tips, various soldering tips. And I will tell you, there is a solder tip that I prefer, or 2 soldering tips that I prefer for this particular job. A solder sucker. I'm not using this as much anymore, but it does help at times. Solder wick. It's a copper braid solder wick. Good rosin core solder. Check this out, Radio Shack. I've had this for a while. I've actually had this spool the longest, though, since probably the late 90s. It's rosin core as well. This stuff is a little too thick for doing this type of component work. Let's see, what else? Flush cut snips. See how they're flush here, so you can get really close to the board. That's good. Maybe some small needle nose. Couple straws. This is very handy. This is they call these pin vices, okay? It's just a small knurled pin vise for really small drill bits. And this particular drill bit here is this top one, 1.05 millimeter. I'll explain that here in a sec. So here we go. Here's how I would do this. I've got this section left. I'm going to eradicate this whole section, just like I did this whole section, then I did this whole section, then I did these few here all at once. I'm going to remove all of these first. So what I end up doing is I end up standing all these up as straight as possible. Okay? And let's start with this one here. Let's talk about this one. Now, if you look, you see the positive to the right. That means the leads are left and right. There they are, left and right, right here. Okay. This is the part that, or this is the situation I don't like, but you end up putting it in this way as well. If you look really close, I'm not sure if this is focusing in the GoPro footage, but each of these leads are bent over, okay? What the idea to remove this is to heat up both of these pads so that they're in a liquid state and pull straight down the old component out. Just pull straight down. Well, with them bent over, that causes a mechanical fastening property, and some friction, and it makes it quite difficult, honestly. So what I do is I first wet one lead and I get under it with my flush cutter here. And I don't know if you can see this. I don't want to do any, too much reflecting, but I'll use one hand and I'll get underneath this and lift while it's wet. You never want to lift it while it's solid. And the reason is you'll lift the pad, the trace, the pad, and you'll damage the board. When that does happen, it's not the end of the world. A lot of times there's still continuity and you can get by with putting a new component in. But you want to mitigate that altogether. You don't want that to happen. So I'll come in here. This is a tip. It's got a little bit of a wedge on the end, so it's not a real thick tip. See, you can there are different size tips. This one here is quite a bit larger. See that one there? See the cone shape on that shiny one at the bottom? This is a little too big, and it's also all conical. I prefer a tip that's got a little bit of a bevel to it. So I'll come in here, fresh solder on here. First of all, I'll clean the pad. I should back up here. Let me go over here. So this isopropyl, right? I put it in a little glass cup here, and I use an acid brush. At least that's what we called it in the service, an acid brush. They are usually like this when you get them. See the long brushes here? And then I take scissors and I snip them off so that they're a little shorter, okay? So I'll come over here, I'll clean the surface with isopropyl. I'll dry it off with a paper towel. I'll come over and I'll add a little bit of flux to each of the pad. Then I'll prep my iron, 330C, clean the tip, shove it in here to get it all nice and shiny, and then I'll put a little bit of fresh solder, not a lot, just a little bit, wet it. That creates a heat bridge. Come over here with this, and it just takes some dexterity. Get underneath there, right there, and then as soon as you wet it, you'll want to lift this lead so it's straight up and down. And do the same with this one over here. Once they're straight up and down, go to the next one. Do all of them. Get them all straight up and down. Clean them all, pre-flux them all, get them all straight up and down. First step. Turn the iron off. Walk away, grab a beer, cup of coffee, whatever it is. All right? Come back. This is cool. You're going to change tips. So I'm going to take this tip out, and this tip is what I use to remove the capacitor. I hope you can see that. Let's see. Yeah, I got my little trusty manual caliper here. 5 millimeters, isn't it? It's closer to 6 mil. So this tip is 6 millimeters wide. Well, a lot of these capacitors, the lead spacing, it's a spec they have for capacitors, is 5.5 millimeters. And if you look, let me touch my anti-static here to keep discharged here. We're looking at about 4.5 to 5 on the spacing. So you're going to come in here now. Just bear with me. Imagine this is in the iron, and it's all tipped, ready to go with some fresh solder, like you see here. You're going to come to this one here, this capacitor here. You're going to grab it firmly underneath. Those leads are straight up and down. Then you're going to come in and this tip will heat both of those pads. Once you see them turn shiny and fluid, you're going to pinch and pull and almost use the bottom of your thumbs as a fulcrum and pull that component straight out. Done. Set it aside. And you're going to march through and do all of them. Okay? So that's kind of the step 2. Now you've got them all pulled. Now the part is clearing the holes so that you could put new capacitors in. By the way, these blister packs or whatever they call them, don't try to pull them out of the paper. Just snip them off right at the paper base. You can see there, see how I've snipped them off. You pull it, you'll damage the leads. You want to keep as little mechanical force bending these leads going into the can down as much as possible. You don't want to wiggle it back and forth too much, okay? All right, so to get the holes clear, well, yeah. I flux a little more. I come back again. I continue using this. And what I do first is I try the solder wick. And probably 30% of the time, the solder wick will come out and it'll wick all that solder through the hole and you'll have a clear hole 30% of the time. Okay, that doesn't work. I take a straw. Used to be this one next, but I found this one a little bit more effective than this. Take a straw. Make sure you don't have a lot of saliva, you know, because you start holding this in your mouth, you're going to have drools of saliva all down this. You're going to wet, and as soon as it's wet, that hole, you're going to get this really close and really abrupt, acute puff, and hopefully that'll blow through. About 30% of the time, that works. Okay? That doesn't work. I will try a suck a few times. Normally that doesn't work, but maybe 5% of the time that suck will work and it'll be clear. So you've exhausted all of those options and it's still not clear. You can repeat those steps and there's a 10% chance it'll actually come clear. But I have spent 20 minutes on one hole trying to clear it with those methods and it still doesn't clear. As a last resort, this. And it's not like all this time. I'm going to wick, no. I'm going to blow with a straw, no. I'm going to suck with the sucker, no. That's all within probably 3 to 4 minutes. Now I'm at this. Make sure that it's clean. And hopefully it's somewhat concave in the hole. If you've added more flux in all of those procedures, come back and wick it one more time so it's nice and concave and flush. That way it's almost like centered. So when you put the drill bit in there, it rests in that concave fillet there, and you just drill it out straight through, you're golden. Do that for all of them. Come back in and you're going to insert the capacitors. Make sure the polarity is correct. On the capacitor, the bar is negative, non-bar is positive. Also, I believe the positive, I hope I'm speaking right here, the positive lead normally is longer. Let's take a look at one of these. Yeah. So if you look here, this one's negative, this is negative here, and this side is positive. And if you see here, the positive lead is longer. But it's really easy just to remember the bar is negative, the dash is negative, negative, right? And you're going to go through and you're going to stick them in. You can have a little bit of relief. Don't flush them all the way, push them all the way down, because it'll spread out those leads and it'll, you know, it'll crack that union that goes into the can. Don't do that. And just bend them over. And yeah, they might be a little loose, but with the leads bent over, they're not going to fall out of the board. Go through and do all of that section and then come through and go, okay, this one here, it's kind of loose. It's, you know, falling down here. So you're just going to kind of hold it straight. Nice straight attitude. Get your soldering iron with this tip again. Load it up with a good bit of solder. Oh, and also, I'm sorry, after you bend them, I go back and reflux those areas with those leads. I even clean the leads. I'm sorry, I didn't tell you that either. So I take these leads and I'll clean them with isopropyl to get any gunk from shipping and, you know, just being on the shelves and in bins off. Stick them in, bend them over, flux, and then come in, hold the capacitor where I kind of want it with a tip that's nice and loaded. Hold it there for about 3 seconds. It'll flow, let go, and then within a second, that solder will turn to a solid, and your capacitor is affixed in the position it'll stay. Now, personal preference, what I do is I'll go through and I'll do the same on one lead on all of the capacitors. Instead of hold it for 3 seconds and then go immediately after that dries, turns to solid, immediately go to this one, because you've got a lot of heat from the soldering iron that conducted into the capacitor. So what I do is I do one, do one, do one. When I come back to this one, it's been, you know, 6 minutes with no heat on it. So it's cooled off now, and I go back and I do all the other leads, just to kind of protect the capacitor best I can. So that's my method. Wanted to share that with you guys. One other thing to share with you guys, in case you're wondering about it, voltage regulators, a very common thing I hear with these Sega Genesis. These two transistors here, see that? Voltage regulators. They're not bad, and they'll probably, they might last the rest of my life. But you know what I did? Well, because they're only $3, I got 2 new ones from Console 5, and then they are the upgraded 2 amp. These are lower, I think, 1/2 amp, 1/2 amp voltage regulators. I got the 2 amp, and I'm going to install those as well. There's a procedure on how to do that with these two, by installing the heat sink first with your conductive paste, and you can just use thermal compound like you use on CPUs. That stuff works great. Screw them into the heat sink while they're not soldered into the board yet, so now they're held in place where they want to be. Don't snip the leads off, they're tall. Solder them all in, flux, clean, all that good jazz. Solder them all in, and then come back with your flush cuts and cut them all off, and you're done. Folks, that's it. I hope that's helpful. Oh, one other thing as far as a tool, obviously you see I've got this circuit board holder here. This is just a cheap $15 holder. It was a very small one, but I modified it with these aluminum angle iron things here, some pop rivets if you see here. I also took part of the base, the way the base works, and I actually took a cross member, and this was the width of the stock one right here, but I added one of the cross members here with a piece of wood as a sleeve to bring that together with some, you know, construction adhesive inside, and that held that together. And then this is just MDF board, and so that helps. If you can get a holder like this, that helps as well. Thanks guys. Got any questions, let me know. Bye.